Okay, so let's say we have an LC circuit and that we have a capacitor of capacitance C star that at t equals 0 is charged to a value, say, capital Q. So there's a known amount of charge, and then we connect it to an inductor of inductance, say, L star. And then at some moment in time, the charge on the capacitor is half of that initial value. And at that moment, let's say we're asked to find the current. Okay, so let's find the current I when the charge in the capacitor is half of the initial value. So the unknown is the current, and so we know that the energy in the inductor can be written in terms of current. And if we use that, then energy conservation tells us that the energy in the inductor plus the energy in the capacitor is equal to the total energy, and that's a constant. So we have the inductance, inductor of inductance L star. We have the unknown current I squared over 2. That gives us the form of the energy in the inductor in magnetic form. We know that we have a charge capital Q over 2 on the capacitor. EC goes like charge squared over 2C, so we have to square this, divided by 2C star. So everything here is known. We have to have a known value for the total energy in order to use this to solve for the unknown I. There must only be one unknown. Well, the total energy can be written in terms of the maximum charge. So, as we've seen before, if we know the maximum charge on the capacitor, and we know the capacitance, we can write the total energy in the LC circuit. But we know what the maximum charge is because the charge on the capacitor obeys this equation. In this case, because at t equals 0, Q reduces to capital Q. And so it obeys this equation. And so Q, capital Q, is Q max. And so we can write ELC as Q squared over 2C star. And now solve for I. We'll take this, bring it over here, so we get a Q, capital Q squared over 4 from this. All right, these 3 2's disappear. We multiply both sides by 2. That disappears. We get a 1/4 capital Q squared over C star here. Here we just get capital Q star over C star. So we have 1 minus 1/4 capital Q squared over C star. That's 3/4 capital Q squared over C star. And that's equal to this on the other side. So without the 2, we have to divide by L star and take the square root. That'll give us that the current in the circuit is plus or minus the square root of 3/4 Q squared over L star C star, which we can simplify a little bit further, but otherwise we can just leave it like that.